All right, welcome everyone. Good afternoon. I'm gonna give everybody just a couple minutes to get loaded in here. All right, well, welcome everyone. My name is Trip Winkler. I'm actually subbing in for Bobby Harris, the Executive Director of UBBA, and it's my pleasure to welcome you to today's webinar. We're excited to have Ken Kaminski, Private Networks Director of Security at Ericsson North America, leading us today. Just a quick housekeeping note before we get started. If you have any questions for Ken during the webinar, submit them using the questions tab in your GoToWebinar toolbar. We'll answer as many questions as we can towards the end, time permitting. But without any further delay, I'm going to turn things over to Ken to kick us off. Ken, take it away.
Thank you, Trip. So my name's Ken Kaminski. I'm Ericsson's Director of Cybersecurity for Private Networks for North America. And we're going to be chatting about security in private LTE for utilities today. So a good starting point is kind of just the changing mobile network security landscape as we're seeing it right now. This technology has been out there for a long time now, obviously for mobile network operators, and it's been deployed globally. And what we're seeing now is that it's being deployed privately for utility networks, primarily for devices and other types of very specific things that are unique to the utility industry. And the security landscape has been changing over time, in particular over the last number of years. So first of all, we're seeing a rising number of targeted attacks because this is critical infrastructure, and these targeted attacks come from very advanced adversaries. Just as an example of that, both CISA and the National Security Agency just recently produced some warnings about a Chinese advanced actor called Volt Typhoon that was attacking U.S. critical infrastructure, in various points around the country. And that's just really one example of that. In terms of these attacks, we've noticed that there has been a shift. It used to be primarily about intelligence and espionage, trying to get into there to see what information you could actually glean. And that has changed. I'll show you in the next slide here a couple of attacks where it went to actual sabotage of the actual utility networks. So, with these targeted attacks, we've been seeing just the frequency and severity of these has been increasing fairly dramatically over the last number of years. A second point is there's been an evolution in the network itself. The number of devices attached to these networks has gone up, and what we call in the cyber industry the attack surface, the available surface for an attacker to actually attack the network, has expanded, become more complex, and gotten more dynamic over time, which makes the networks more difficult to actually protect. And then lastly, there's really been an increase in just stricter regulatory requirements. The regulators are very aware that these are critical networks, the power grid. I don't think you can get more critical than that. And the importance of those in terms of critical national security infrastructure is not lost on them. So we've seen just a movement from relying on voluntary guidelines to more regulatory regulations and things like that, looking at more fines, more C-level accountability and the like. So just that regulatory environment has tightened over time. And then if we look at just some of these attacks that we've seen in just the last 3 or 4 years or so, some of them are interesting. You've got your traditional IT-focused ones over there on the left, and most of the US tier ones have been hit where attackers have gone in and stolen personal information from subscribers and whatnot. That was generally the goal there. Those attacks are generally more IT focused, and the losses can be fairly significant. There was one incident where it was about 500 million in costs to the actual operator. Some of the more specific ones targeted at the cellular infrastructure, you've got a particular threat actor called Light Basin. That's actually a Chinese operated advanced persistent threat actor. And this particular organization actually compromised about 13 different telecom companies. They mainly got in there for espionage reasons. They were looking for information, in particular on, what they could collect on, certain individuals and things like that. They were looking to steal things like subscriber information, call metadata, information about the calls, who's calling whom, and that. And they moved around those networks for a good, from about 2016 to about 2021. And that was primarily espionage related. You've got false base station attacks, a lot of them related to what's called smishing or SMS phishing, where they want to send targeted texts in order to get someone to click on something that they don't. And then you've got these two, which are of interest. You've got Vodafone Portugal and recently Kyivstar in the Ukraine, which was last December, in December of 2023. And in both of these attacks, the attacker actually brought down the underlying infrastructure that belonged to the operators. So they brought down the main applications that were running these cellular networks, and the attack was designed to actually get in and cause destruction. So you had outages, in particular with Vodafone Portugal, of about 5 days, and in the Kyivstar's case, that was about 7 days. And that's a shift because we've seen prior to this, it was mostly about espionage intelligence, and these are more like an attack to actually bring the infrastructure down. In the case of a wartime environment in the Ukraine, but it was not a wartime environment for Portugal. So that's a shift we've seen. Now, these private utility LTE networks, these 4G networks, are made up of these main components. So over on the left, we have the devices, and this is where it's quite different from a regular mobile network operator, where you have primarily things like smartphones and tablets that are attaching to those networks. On the utility side, we don't see many of those. Sometimes we'll see some, but it's mostly IoT devices. These are various types of devices that are monitoring the grid, for example, and doing different jobs within the electrical grid. And then we have these things called mission critical push-to-talk devices. So these are the devices that the crews, as they're out there operating, and maybe after a storm, they're operating in a geographic area. These are these push-to-talk devices that they're using for their critical communications. And that's primarily what we see on these types of networks. They'll connect into the radio network, the cellular radio network, and that radio will connect down to a device that's called a baseband. And that baseband device basically is converting those radio signals to regular IP packets that are going out on the data network on that interface that's connecting to the actual utility's private IP backbone. Those backbones are usually using a technology called MPLS. That's just a way of routing and connectivity. And then that will connect across that. That's usually fiber in most cases. And then we'll connect to the data centers of the utilities. And within those data centers will be what's called the cellular core. That's what we call it in the industry. And all that core is made up of is a bunch of applications that are running on a cloud-based Linux environment, running the Linux type of operating systems, using a technology called Kubernetes. So all of these particular applications are running as containers on top of this cloud-based architecture there. And then you'll have your connection into the internal utility network over on the far right. So from a high level, that's what it looks like. And that's the network that we're looking to secure. When you are looking at a vendor, how do I, what types of things should I be thinking of with the vendor? And the vendor that's actually going to build out this infrastructure for me. And it's good to think about, all the different processes along the supply chain that help to enforce network cybersecurity. And we like to look at it this way. So it's built on a foundation of standard protocols. In the cellular industry, there is an organization called 3GPP that defines all of the standards that we build these networks to. And they're multi-vendor by nature, so they have to be able to interoperate. So these standards are absolutely critical. These same standards actually bake security fundamentally into the entire process. So they'll define things like secure protocols, algorithms, and different features and functionalities. And then on top of that, you've got your look at the vendor product development process. Are they doing this in a secure way? How are they building their products and components? And then there's a deployment process. So how is that vendor going about in terms of the network design from a cybersecurity standpoint, configuration of all the right parameters, and then the deployment of that network? And then lastly, there's ongoing operational processes. How's that vendor doing in terms of just the day-to-day keeping of that network up and running? And in terms of protecting the utilities data, for instance, that the vendor might be using. Things like response and recovery after breaches, all of this come into play. And how do I know that a vendor is actually doing the right things that he should be doing? Well, in the IT world, we have various standards that we'll go ahead and measure an organization by. A lot of these are from organizations like ISO, and there's a standard called ISO 27001 that dictates all the different ways a company will run its IT security side of the house. Well, the same thing exists within the cellular world, and there is an audit, a certification audit called the NESAS, which stands for Network Equipment Security Assurance Scheme. And this is run by an organization called the GSMA, and they have a classic audit that the vendors like ourselves, like Ericsson, would undergo. And it looks at all of these aspects. What's your development process like? Is your coding secure? What's your build environment look like? What about all of your security documentation? How do you handle vulnerabilities within the software? Information security management, staff education. You see all these different pieces. So you as a utility can look at this, and this is, by the way, posted publicly. So you can go ahead and you could look at, the vendor that you've chosen and see how they do on a NESAS certification audit, and that will give you a level of assurance that the vendor is doing the right thing in terms of how they're building, designing, deploying, and then maintaining these private cellular networks that the utilities are in the process of deploying right now. So that's a really good thing to know about and to check out. Now, if I'm a cybersecurity architect and I've been given the job now of securing this private cellular network, at a very high level, there are three models that cybersecurity architect will look at as he builds all of the various cybersecurity controls that's needed to actually secure the network infrastructure. In the utility industry, we're quite familiar with the bottom one. That's the NERC CIP standards. There's a number of these. These focus on the bulk electric system side of the house there. And we're very familiar with those. Those are already built into our processes. And the next one up is being built into the processes right now. It's something called Zero Trust. And this was standardized by NIST in a document called NIST 800-207 a number of years ago. And it's a different, more advanced way of looking at cybersecurity in the sense that you're taking it from the standpoint that you already have attackers inside your perimeter to begin with. So there's a lot more advanced security controls that it's calling out in order to do that from that fundamental mindset. And I'll show you what a couple of those are in a moment. This is moving into the utilities industry, and it has been over the last couple of years. And the US government is very hot on this. They have mandated this across every federal organization, and we can expect at some point they'll be pushing this way of doing cybersecurity, down into the various critical infrastructure verticals that are out there, including the utilities subsector. And then the last one this cyber architect has to be concerned is what about all of this very specific cellular network security controls? And these are defined in a couple of documents, and the most important ones are right there. 3GPP has a document called TS 33-.401, and that's for 4G systems. 5G is the 501 variant of that. And that document is very long, and it includes everything that is mandated by the standards from a cybersecurity aspect that has to get built into the overall cellular network from an end-to-end perspective. So it's something that the cyber architects for the utilities will want to get quite familiar with. So that cyber architect, he's going to be balancing all three of these as he's looking at, how do I secure this private cellular network that I'm rolling out right now? The standard way of kind of looking at the world is really caught up in the NERC CIP standards. And the NERC CIP standards have this concept of an electronic security perimeter, or an ESP. And all my traffic coming in and out of my more secure areas have to go through this, and they come in and out something called an electronic access point. And this viewpoint is a pre-zero trust viewpoint. So it's built around more or less a castle and moat architecture. So I build these perimeter defenses, and then what I do in order to make my network more secure is I might have a couple of perimeters. And then I'm going to build all my controls right on those perimeters, and that's how I'm generally going to secure the network. It's often compared to like a castle and a moat, where you got the castle, you've got a moat, and then you've got walls there. And if you breach the walls, then you're generally inside the actual network there. Zero trust, like I was saying, is a different way to look at it. Because what we've learned with all of these advanced attacks and these advanced attackers is that that is not sufficient, that older way of doing things. And we really need a newer way that looks at a much more advanced way and actually assumes that the attacker is already inside the network and will build controls and protections accordingly. So instead of having, maybe one or two of those perimeters, there's this idea of a pomegranate. So versus a coconut over here on the left, we may have one hard shell. You've got with a pomegranate, there's all these different smaller perimeters on the inside. And this way of doing things and building things is a lot more secure than the way here on the left. You also have ideas like continuous monitoring. So we're always getting information from various points in the network, and we're always constantly looking at those. We're not just doing like a security audit at one point in time. We're going to do it every 6 months on this date. That doesn't work in the modern world. What we really want to be able to do is always constantly be able to be monitoring all of that information from a cyber perspective. And some of the controls that are used in this way of thinking or this new architecture are things like these. So like in a traditional mobile network, what we would look at is we just really authenticate the device to the network. So the mobile network operator wants to say, is that device authorized basically to connect to my network? So we're really just authenticating the device. Anyone could be using that device. Whereas in a zero trust environment, there's a mandatory architecture that looks at, we are going to authenticate every device. We're going to authenticate every user that's on that device. And then every individual application that's running, we're going to authenticate and then authorize or give credentialed access, what they can access within the network. We're going to do that on a per application flow basis. So you got all three of these that are running, and these are called micro perimeters because you've got really a perimeter that exists right at that application flow level going across your network. So it's a lot more secure. There's a mandatory rule here to encrypt all of the transactions and flows. We're going to encrypt everything. We're going to do segmentation not only, around that hard or outer perimeter. We're going to do segmentation inside the network at various pieces. We're going to automate everything. So automation is a major idea here. Modern networks are just much too complex to try and do things from a manual perspective. And then we're going to log everything. We want to be able to log as much data as possible and then look at that data on a continuous basis. And that in the industry is called continuous monitoring. We want to be monitoring that on a continuous basis. So those are the overall cyber architectures, kind of the way we look at the world as we're building these networks out. Let's look at a couple of concepts as we get inside the cellular network. First concept here is we keep the management network. We call this the OAM management plane. And we're going to keep all these interfaces in a completely separate segmented network. So the network that the actual control and user traffic is actually flowing over is completely separated from the management network. You just can't get there from one to the other. And this allows a very high level of security, keeping that management plane completely separated. We'll also have another network segment that's going to separate the network that's running to a mobile network operator roaming partner. Because a lot of times these networks are architected so an IoT device that's out here monitoring the grid, if it can't find the private network, it'll be able to roam automatically over to a roaming partner, and in that way keep the connectivity and that availability at a very high level. Within that management network, we have some major ideas here. So not only are we keeping it completely separated and segmented, but we're also making sure that we use, very advanced certificate-based authentication in order to authenticate and authorize all of those humans and even the machine-to-machine connections that are going on within that. And that authentication architecture will integrate with the existing utility architecture that's already set up. Normally, that's something like a Microsoft Active Directory environment. So all of the users will live there, and then we'll base all of the various users and what they can access off of that system and use it within the cellular management system. All of the communications that are running over this management network also are only using modern protocols, things like TLS, SSH version 2, SNMP version 3. All of these are using modern authentication, generally with certificates, and they're all using modern encryption and integrity algorithms. So nothing goes over that network that is not protected and not encrypted. When you think about connecting your devices to the network, this is what it kind of looks like from like a device perspective. So I have this IoT sensor that's out there. It's monitoring maybe a piece of the distribution grid. That's going to connect to the cellular network, and it's using this thing called a SIM card. Where the actual security mechanisms exist within a piece of hardware that's protected on this card, and that links up with the security mechanisms that are found over here on the core network side of the equation. And they're going to link up and they're going to build an encrypted and integrity protected tunnel that's going to go over the air, and then it's going to go over this piece for the signaling network also. And then at a very higher level, one of the things that you as a utility operator want to think about is the devices themselves. When you purchase them, CTIA is an organization that has a guide. It's a certification program where they certify all of the various cybersecurity features and functionality for IoT devices. And they break it down into level 1, which is a little bit more basic, and then level 2, which has some more advanced cybersecurity controls. One of the things you're going to want to do when you're purchasing these devices is you want to make sure that they adhere to this. Because when you buy something that does, then you can have that higher level encryption that's going on with the application that's running on the device. So you can be running here from this client, the application, all the way to the server, and this can be individually protected using modern encryption algorithms like TLS. And in that way, you get that zero trust architecture. So you've got encryption that's actually happening at that application level, not just at the device level, that's happening down here over the air going to the cellular network. You've got this multiple layer of protection that's actually going on there. Now on this radio side of the house, you'll see here down below, we've got encryption for the radio signaling going over the radio. And we've got encryption also for the user plane. So these are the actual data packets that the actual device is sending. So these are encrypted and integrity protected going over that. That's going over the radio side. On the top, this top bar here is showing you another connection, and this is all the signaling, all the control signaling that's happening between the device all the way to the core network. That is also protected with encryption and integrity. And what is encryption and integrity? So these are happening going over the air and then also over the network for the signaling link there. They're happening in a sequence. So the first thing that happens is the integrity piece. And all that means is there's basically a hash that's run on those frames that are going across the network there. And it basically does a hash and it checks it when everything gets to the other end. So it's making sure that all of those bits that went up in the air, they actually traverse the air and get to the other side and everything's good over there. And that's called integrity protection. The second thing that's happening right after that is encryption. And that's where we're actually encrypting and protecting the traffic so that if someone intercepted it, it's just a jumbled random mess. They're not able to look inside and decrypt that and then figure out, what was actually sent there. The actual algorithms that are used by the cellular vendors are standards-based algorithms that you're used to on the IT side. So we use what's called the AES algorithm that's used very widely in your current IT deployments. We're using that same algorithm here to protect the cellular network itself. When you're looking also at the actual radio towers that are out there, so you've got those radios and they're connected to those basebands. And those basebands, remember, they're going to spit out regular IP packets that will go and traverse your regular network. These are built with additional security mechanisms that you might not find inside the network in the core portion of it. The core, usually that's living within the utility data center, And around a core, being that it's in a data center, there's a lot of people and other security that's around that. Versus these sites out there, they're often unmanned. They have perimeter fences and cameras around them, but they're not, you just don't have people that are out there. So because of that, we build a lot more security features and functionality into them from the get-go. And some of those are listed here. There's more hardening that we build into these in terms of just hardening the overall protocols that are allowed to run, which ports are allowed to be open on that. There's more features in terms of secure storage, encrypting the security logs, not providing access to the underlying operating system and file system. Just a lot more controls there. One of the major things you'll see here is what's called in the industry a hardware-rooted secure boot. And what that basically means is that you have a piece of hardware on that baseband, and that hardware has the secure keys within it. And if I attempt to load up any piece of software, any piece of firmware, even a software patch, really anything at all, I try and load that on the device from a normal vector, or if I'm an attacker that's somehow gotten in there, I'm trying to load my code up on there. This particular feature is really the state of the art in stopping that, because it's rooted in the hardware itself. What that means is getting that software onto that is incredibly difficult. You have to breach the security of the manufacturer's key system in order to do that, and that is incredibly difficult to do. So these features are really designed with the idea that these are out on unmanned sites, so we have to build more security into the technology that actually goes out there. As we move into the network now, so we chatted about the radio side here. Now we're coming off of this baseband and we're connecting across the utilities infrastructure. And we want that to be encrypted too. And if you want that to be encrypted, we're going to use this thing that we call in the cellular industry a SEG, or a security gateway. And all that is a next-gen firewall from the firewall vendors that you're used to buying them from. So from the Junipers of the world, or the Ciscos, or the Palo Altos, or whoever they are, they all have software loads on their products that understand some of the unique protocols that run on these cellular networks. And you just buy from them this functionality. So instead of buying your regular IT variants here, you're buying the cellular network variant. And the way that this would work is we would just build a tunnel with a protocol that you're very used to using within the utility networks called IPsec. And that is built into the baseband, and that will connect all the way to this next-gen firewall called a security gateway. And in that way, we can encrypt everything going across this portion of the network. And then over here on the right, this is something that we highly recommend the utilities deploy, in particular when you're thinking about that zero trust architecture. We want to build more internal segments that isolate the cellular network from the rest of the utility operational technology, or OT network. So we recommend that you put a firewall right there coming off of the core at that point where it's connecting into your internal network. And in that way, you can protect the cellular network from the rest of the internal network and have those security controls right there. What we've noticed, and this slide comes from from my perspective of working for Ericsson, we've deployed a good number of these networks right now. And we've noticed a couple of patterns as we've watched this kind of roll out. And one of those patterns is we've noticed that there's a very lengthy process that utilities go through in order to basically go before like the various commissions in the state. to get the money to actually build the networks. They have a pile of money. And what we noticed in these initial builds is they were forgetting certain aspects of cybersecurity that were required. And then there was a rush after that to actually go ahead and build them in as kind of a phase two. And that could be difficult because the money is generally available up front, so you want to do it all up front. And the utilities would ask us and say, well, how much of the costs, should I look at, in terms of a percentage? If my network that I'm building is 40 or $80 million or whatever, how much of that should be related to cybersecurity? And we have some internal numbers, from Ericsson, where we've done some surveys over the years. And the mobile network operators have tended to spend, this is some old data, back then it was about 3% of the total costs would go to cyber. So 3% of that. A more modern number, because cyber has become so much more important, is about 5%. So a good point of reference is to say, okay, I have this budget, 5% of that should be going to cyber. And the things that we noticed were getting that were not that were being left out were these. So there was that security gateway if they needed that, they were forgetting that one. So those next gen firewalls have to be included. There was some other next generation firewalls. I talked about the one that connects to your internal segment there. There's another one on the roaming side that I'll talk about in a moment. And then there were these use cases that are very unique to the actual cellular network themselves. And these use cases are not covered by the existing IT tools that the utility has deployed. So utilities have very extensive cybersecurity tools and architectures that are already built out. Those are built primarily for the IT and the operational technology side. They do not cover these 4 use cases. So in order to cover these use cases on the cyber side, you have to include these. And then there was the need for network taps. If you are actually tapping the core, I'll talk about that in a slide. And then you also needed to think about the security for all of those devices that were out there. And I'll talk about that in an upcoming slide. So first off, let me talk about these use cases. And these use cases will be built into a product that you're going to buy from the cellular vendor themselves. So the cellular network vendors have products that will handle this. In the Ericsson world, we call this Ericsson Security Manager, but that's just our name for it. And it's designed to operate with your existing security ops center, your existing SOC, where you have this thing called the Security Information Event Management Platform. This is a piece of technology that's looking at all of your logs and pieces of information coming in from all various parts of your network, and it's analyzing those and looking for attacks. And this product from the cellular network vendor will, in essence, work as a sub-product to that existing vendor. So it will handle these use cases, and then it will go and notify that particular vendor technology when it sees an attack within the cellular system. And the types of things that it's looking for are these. So we're looking at things like attacks on that management plane. So that separate management network is a big one here. Any attacks that's going there, this already has the rules built for all of the vendor gear that's out there. And it can look for that stuff and then tell that, that security information event management product that I see a threat. If you don't have a product like this, the utility engineers are going to have to write all of those rules themselves, because these rules don't exist out of the box. And that can tend to be a huge effort on the part of your existing engineering staff. So there's a real benefit from letting the actual cellular vendor do this for you. This provides also these things called endpoint detection and response agents. These are agents that run within the core applications that are there, and they're looking for those advanced actors that are trying to get into the network. Just to give you an example with this is that all of your cyber insurance companies that are out there, they demand widespread deployments of these EDR agents within infrastructures, because these are the primary pieces of technology that will find those real advanced actors. This will detect false base stations also if you've got false base stations running out in your network. And they also automate the configuration and the configuration auditing piece of deploying the network. This is usually done manually. And the way that it's called baseline automation. The way that this works is it will look at all of the devices and applications that are out there. And what it will then do is make sure that the configurations of those for all of the security configurations are done properly. And if someone changes them, periodically this will go out in the network and it will reconfigure those the way that they're supposed to do. So it basically automates that, so you're not manually checking are all of these things configured right, and it just automates that entire process. So all of this is included within that cellular use cases by the actual cellular network vendor. Sometimes also you have a requirement within that cellular core where you need to drop what are called network taps in there. And those network taps are usually going to vendors like NetScout or Gigamon or someone that's out there. And if you attempt to do that on these Linux containerized environments that are out there, all of the traditional ways, they don't work, because you just can't grab one interface and then tap it. These containers could be running across multiple physical servers underneath, and you need a software feature that can basically channel these interfaces and then send them up to your vendors. So if this is a requirement, you actually have to define that and let the cellular vendor know this is what you need to do on your core. Now the last piece here is just the view from the device side of the house. And the way that a mobile network operator looks at a device that attaches to their network and the way a utility looks at that are completely different. A mobile network operator only cares about the actual device itself, and they're just looking at that SIM card that's in there. And they're basically saying, hey, is this a device that's authorized to connect to my network? They don't care about any applications that are running on that device. They don't care if someone else is using that device. They just care, is that device allowed to connect to my network or not? And then they also care about making sure that you don't take that SIM card out of that device, put it into another SIM card, and then get connectivity to the network there. And they have mechanisms, we've got mechanisms that we've built into these networks for a long time that can look for that. And there's a function within them called the Endpoint Identity Register. It's an application that runs on the core that will tell you if someone's playing any games there, if they're pulling the SIM card out and putting it into another device. But this is really all a mobile network operator cares about. But if I'm a utility, in this zero trust world, I have to authenticate every device user and application. So I care a lot about this device. And I generally have software running on all my devices where I can look and make sure that anyone that's on that device is a utility employee, and I've got security software on there that's actually, looking at and making sure that no bad code or malware is getting on those devices. I've got all sorts of controls on those devices in an enterprise. And for devices, for instance, like tablets or mobile phones, there's a whole class of security controls from vendors called mobile device management, or MDM vendors, that are out there that'll put a little piece of software on there, and they'll do all of those security controls on that smartphone, for instance. But we got a problem here in that IoT devices, they can't run any of those agents. And there's hundreds of thousands, we're looking at networks with millions of these devices, when they're fully built out. And we've got to have a way to secure those devices without running those traditional controls on top of there that we can do for things like smartphones and tablets. So we have to be able to provide these controls for all the devices that are out there. And there's a number of solutions that are out there. There's two vendors in particular. OneLayer is an excellent, security vendor that will basically connect with the mobile core and do this. Palo Alto also has a solution out there to do a similar thing. And we expect as time goes on, there'll be more. But the way that these devices or these vendors operate at a very high level is they drop their product in here, and then they're going to talk to the mobile core. So these are the applications that are running the network. They're sitting within the data center, and they are going to do two things. The core is going to send them information about the signaling and the user events that are happening here. So they're going to look at that. And then when they see something bad going on with one of their devices, they're going to be able to do a security policy device enforcement action where they're going to come back the other way, and they're going to tell the core to do something, or they'll block it, maybe on an existing firewall. And so they could do something like they could just deactivate, for instance, the cellular subscription for that particular device, and in that way isolate it. Or they could tell one of these firewalls here to actually do something and to block that device. So at a very high level, that's what's actually going on. The vendor is getting information and then sending a security policy control action going back the other way. Okay, and then the last major piece here that I wanted to chat about was you have to have a firewall between your utility network and whoever that roaming partner is. Because the way that a lot of these networks are going in again is a device could be out there and it has mechanisms within it. It's going to connect primarily to the private network. But if for some reason that network goes away, it could connect to another mobile network operator within the actual range of that device. And if it does that, it has to be able to talk to that network. So there's a signaling connection here that goes out from the core to that mobile network operator. It uses a protocol called diameter. And that's just a variant of a protocol called Radius that's used within your existing cybersecurity architecture. That's just a telecommunications variant of that protocol. So there's signaling that happens there, and then the traffic has to come back around, and that's coming in a protocol called GTP. And so that's diameter is the signaling, GTP is the actual packets. So this information is going back and forth between the roaming partner and the utility, and you'll want a firewall here. Again, this is a firewall from your existing vendors. So they all understand these protocols. You just have to ask them for the right software load to actually load up on it. It's not the same load that you'll be using on the IT side of your house. You're going to ask for the one that supports these protocols that's designed for a cellular network, but it's the same vendor. So you're going to go ahead and put that right in there. And then you're going to, if you want this to be encrypted between you and that partner, you'll use that classic IPsec protocol to encrypt everything going between you and them. And you'll want to include that within your security network. So just a couple of points to just finish up on here. The private cellular networks, first of all, one major point is there's a lot of advanced security features that are built into these networks per 3GPP specifications. And then the vendors that are out there will add some additions also to that, according to their product lines. But cellular networks from the get-go are considered critical infrastructure in all deployments and countries. Because of that, they have a lot of security features and functionalities built into them right from the get-go. Second point is, as you're designing and building these networks, the telco world they have different standards, and the telco world loves acronyms. We have acronyms for everything under the sun. There is a little bit of a learning curve on that, but they're similar to a lot of your enterprise IT and OT standards and technology. So like I showed you the NESAS stuff, that matches up to like the ISO specifications when you're seeing how does a vendor run their cybersecurity in terms of their development and product deployment and things like that. You just got to figure out which one matches to the existing one and which one goes there, and they're doing very similar things. So there's a little bit of a learning curve, but it's absolutely doable, and you can pick that up. And lastly, when you are actually putting out your tenders for these networks, don't forget these additional components. So these additional next-gen firewalls, these additional cellular vendor security use cases, you have your device security components. Do you need to do network taps? Ask yourself, do I need these things? And if you do, make sure it's in there, it's in the tender, and it's included up front within the actual budget. And with that, I'm going to end my presentation. Are there any questions out there, Trip?
Thank you, Ken. Yeah, it looks like we have a couple here and just a few minutes to spare to take them. So I'll read them in order and exactly as written, and we can go from there, see how many we get to.
All right,
First
sounds good.
question. Do you recommend we make sure to buy level 2 certified equipment, or is level 1 sufficient?
That will depend. It's kind of it's a little bit of a dodge there, but it depends. It depends, what that device is, what it's doing. Each one of those will add certain amount of cost to it. From a cybersecurity perspective, you're going to ask me, I'm naturally going to want a level 2 device, but you may have a lower, just kind of a device that's not doing much in terms of, its functionality, that you might be able to get away with something less. So it really depends on the use for it. I prefer
Right.
level 2, but I'm a cyber guy.
There you go. Well, it looks like we got a follow-up to that. I'm just saying for CTIA. And now let's see. I think we got, yeah. Do you want to elaborate at all on that, or should we tackle on
CTIA, yeah, they're the ones that actually wrote the spec for that. So they have a document that's out there, and in the slide it's referenced there. One of the things you can do when you purchase the devices, so you're generally talking to vendors like Landis and Gear, Itron, and those folks, and they're building these things into their devices. So it's not like they're not, they are. They've seen the need for it. When you're looking at buying those devices, make sure that they are certified to the level that you're asking for. And there are labs out there that do that. For instance, Ericsson, as our labs on the utility integration side of the house, we can offer this as a service to utilities. There are also other labs out there too.
Perfect. Well, I think we've got time for maybe one more question here, and that is the security information event management solutions that we use in the Utility Security Operations Center have significant investment and costs. How can the cellular network vendor integrate with them and be cost effective also?
Yeah, that's a very good question. So those particular pieces of technology, that's called a security information event management system. They come from vendors like Splunk is one of the leaders in this space. There are a number of others out there. IBM QRadar is another. And I apologize, if I'm missing anyone. I'm just kind of chatting off the top of my head there. There's a lot of significant sunk cost into those. And they often operate on an economic model where it's by the amount of information that you're sending into them that the cost goes up. So if you send a little bit into them, it's a lower cost. If you're sending a huge amount of information in, your cost can go up, and you can that can be very expensive on the budget side of the house. So the way that we recommend that you do this is that you look at that cellular vendor that's doing that use case. That cellular vendor is sitting in essence in front of that existing vendor. It's getting all of that information from all of the various logs coming in. You want to do it so that only the notifications and alerts are going up to that SIM vendor. And that's very low volume type information. And then when you're storing all of those logs, because we do have in the utilities, you have a mandatory requirement to store those for a certain amount of time usually, and that's per utility procedure, per standard, and it's usually different per the types of log information. So you'll send it out from the cellular vendor directly to some long-term storage within your architecture. And in that way, you'll keep your costs, minimized, and you won't break the budget in terms of that.
Excellent. Well, I think that's going to about do it for all the time we have for questions, Ken. Any last thought, any parting thought for everybody?
Just that this is coming. It's doable, and you can secure this. Don't forget your cybersecurity. The various cybersecurity tools, requirements, features, functions. Make sure everything's included in your bid when you do it right up front.
All right. Well, thank you again, Ken, for taking time to share your insights with everyone today. As a reminder, you can continue the conversation from today at this year's UBBA Summit and Plugfest, November 5th through the 7th in Kansas City. Visit ubbaplugfest.org for more information and to register. Thank you, everyone.
Thank you.